Welcome back, children. Today we are going to learn a new theory on production function based on the concepts of total productivity and marginal productivity. And I told you there are two time factors in economics. One is short run and one is long run. And we are going to learn a theory on short run, which is known as the law of variable factor. Now, the theories of production function is discussed under two headings. First one is returns to a factor and returns to scale, as we discussed in the last video. I have already mentioned you about the theories in the production function, which is returns to a factor and which is returns to a scale. Returns to a scale is out of syllabus, it is not there for you to learn, but we need to learn returns to a factor. Now, the theory law of variable proportion is the one which we are going to learn, and it comes under the law of returns. Now, to a factor. Now, let us see what is this law of returns to a factor and the law of variable proportion. Now, law of variable proportion, which is learned under the returns to a factor. Let us see what is this law of variable proportion. The law of variable proportion states that as we increase the quantity of one input, keeping all other inputs fixed. Once again, as we increase the quantity of one input, which are the major inputs that are used for production process: land, labor, capital, organization. You know that four factors of production. Now, as we increase the quantity of output, if a producer is trying to increase the quantity of output by changing the quantity of one input, as we are increasing, the law states that as we are increasing the quantity of one input by keeping all other inputs to be fixed. So here the input which we are planning to change is the variable input. Which is a variable input that is discussed in the relationship between TP and MP. The variable input is labor, which is a fixed factor we have discussed, that is land. So there are two factors of production which we have discussed in the relation between TP and MP. One is labor and one is land. These are two inputs required for the production process. In that, the labor is a variable factor and land or machine we can use, it is a fixed factor. Now here the law of variable proportion says that when we are increasing the quantity of one input, the input that we are going to increase is labor, the variable input. The law states that as we are increasing the quantity of one input, keeping all other inputs fixed. All other inputs means land, machines, all other inputs are kept to be fixed. The total product, what happens to total product? That is what law of variable proportion says. If this is a situation, it is a situation by keeping all other factors to be constant and by changing one variable input. All other factors which are kept constant is fixed factors like machines, land, all those are kept to be constant. Which is the only factor that we are going to change here? Labor. We are going on increasing the quantity of labor and we are trying to keep all other factors to be constant. In that situation, what happens to total productivity? The total productivity initially increases at an increasing rate, then increases at a decreasing rate, and finally it falls. So what is the behavior of total productivity when the quantity of one input is increased, variable input is increased by keeping all other factors such as fixed factors to be constant? What happens to the total productivity in that situation? The total productivity will initially increase at an increasing rate, then increases only at a decreasing rate, and finally it falls. So automatically when TP is showing a change, marginal productivity also will change accordingly. Now we have learned about the relationship between total productivity and marginal productivity in the second video. on the basis of the same topic and the same table and the same video, we will be explaining the process of law of variable proportion. There is no change at all. The relation between TP and MP says about the law of variable proportion. And you might have learned you may remember the relationship between total productivity and marginal productivity, which we have seen in the last video, which we have learned in the last video. Now, once again, I am explaining the law of variable proportion. The law of variable proportion says that what happens to a total productivity if the producer is trying to keep all other factors to be constant, such as land, machine, etc., and trying to increase his production by increasing only one variable input, that is labor. So, in the factors of production, labor is the only factor which is going to increase, and all other factors are kept to be constant without changing. In that situation, what happens to the total productivity? The total productivity behaves in three stages. The first stage is increasing at an increasing rate, second stage is increasing at a decreasing rate, and finally total productivity falls. So subsequently there will be change in the marginal productivity too. Now let us explain this law with the help of a table which we have learned in the last video. Now before moving on to the table, I told you all the theory in economics works with certain assumptions. Okay. Now which are the assumptions of the theory? The first assumption is the law works in the short run. The law is working in the short run. You know what is the definition of short run and long run. Then, so in the short run, some factors will be fixed and some factors will be changing. Which is the factor that is changing here? Labor. Which is the factor that is fixed here? Machines and land. What is the peculiarity of long run? In the long run, all the factors will be changed. But here we are discussing the theory under the short run. Short run means it is a time period where some factors will be fixed and some factors will be changed. Here the changing factor is labor and the fixed factor is land and machines. Now it applies to the field of production. This law is applied only to the field of production. Now only one variable input, keeping all other factors to be fixed. So the theory works under the assumption that only one variable is changed, one variable factor is changed, all other factors are kept to be constant. So here we have taken the variable factor as labor and the fixed factors as land, machine, etc. Now next is all factors are equally efficient. All the factors which are used in the production process are equally efficient. All are equally important and all are equally efficient. Next one is technology remains to be constant. There is no change in the technology. So based on these assumptions, we can explain the law of variable proportion. Now this is the table. Now fixed factor, say for example, we will take the case of a machine. It will be 1, 1, the same figure throughout. Now variable factor, we can assume it as labor. Okay. Now here the values of total productivity is given 10, 30, 45, 52, 52 and 48. The same table which we have learned before. Now let us see what is the marginal productivity. Marginal productivity is 10, 20, 15, 7, 0 and minus 4. Now you know how you got this marginal productivity. MP is equal to, you know what is the equation, isn't it? Delta TP by delta L, isn't it? So how will you get that? 30 minus 20, isn't it? Then 2 minus 1, 1. What is 30 minus 20? 20. 30 minus 10, 20. What is 2 minus 1? 1. So 20 divided by 1, 20. Delta TP by delta L. With that formula, we have found marginal productivity. Once again, delta TP, 30 minus 10, 20. Delta L means 2 minus 1, 1. So delta TP by delta L is delta TP by delta L is equal to 20 by 1 is equal to 20. That is what we got here. Similarly, 45 minus 30, that is 15. What is 3 minus 2? 1. So delta TP by delta L is 15 by 1 is equal to 15. So you know very well how to calculate marginal productivity. So based on the calculation of marginal productivity and the values of total productivity, we have divided into 3 stages. We have divided the following into 3 stages. Let us see the first stage, which we can consider it as phase 1. PHASE, phase 1. We can see increasing returns to a factor. What does the theory says? The law of variable proportion says that when we are trying to increase a quantity of one variable input by keeping all other factors to be constant, total productivity will increase at an increasing rate initially, then increases only at a decreasing rate, and finally it falls. Now based on that we can explain the phases. This is phase 1, and I told you when total productivity is showing a change, subsequently the marginal productivity also will be following the same path, isn't it? Because you know both are related to each other. Now first phase, for the first and second variable input labor, the marginal productivity is 10 and 20 and total productivity is 10 and 30. Now here you can find in the first two variable, for the first two variable you can find total productivity has increased from 10 to 30. What a jump from 10 to 30. What a jump means? 20 is the jump from 10 to 30. Therefore we can say total productivity is increasing at an increasing rate. The first statement of total productivity in the law of variable proportion. Then what happens to marginal productivity? Marginal productivity also increases from 10 to 20. Okay. Now the second stage we can find with the variable input 3, 4 and 5. So this is first labor, second labor. Then we are adding on the number of labors from 3 to 5. What happens when we add on labors? We can find total productivity is increasing from 30 to 45, then from 45 to 52, then again from 52 to 52. See, from 30 to 45, the increment is 15. Now, next you can find from 45 to 52, the increment is 7. So, we can say that total productivity is increasing but at a decreasing rate. Okay. Now, what happens? Second part of the law of variable proportion with corresponding to the behavior of total productivity. What happens to marginal productivity at that time? We can find from 20 it is falling to 15, from 15 it is falling to 7, from 7 it is falling to 0. So when total productivity is increasing at a decreasing rate, what happens to marginal productivity? Marginal productivity is decreasing, which reaches finally to 0. And I told you can connect it to the law of diminishing marginal utility when you have learned about the consumer equilibrium, isn't it? Now we have learned the same topic in the last class. The topic is the relation between total productivity and marginal productivity. Now let us see when we are adding on the sixth labor, the variable factor, what happens to total productivity? Total productivity falls from 52 to 48 and marginal productivity becomes negative. It is based on the stress given on marginal productivity. We have written the third phase as phase of negative returns, because only marginal productivity can become negative. Total productivity will not become negative. So we can divide the phases as phase 1, phase 2 and phase 3. So in phase 1 you can find total productivity is increasing at an increasing rate. In phase 2 you can find total productivity is increasing at a decreasing rate, and in the third phase you can find total productivity is falling. So subsequently what is happening to marginal productivity? In the first phase, marginal productivity is also increasing from 10 to 20, where total productivity is increasing at an increasing rate. In the second phase, marginal productivity is falling, but total productivity is increasing only at a decreasing rate. And in the third phase, the marginal productivity becomes negative, but the total productivity falls. So this is the phase 1, phase 2 and phase 3 explanation. Now based on the diagram we can explain the same. See the diagram. Now this is the diagram. Now in the diagram I have marked the phase 1, phase 2 and phase 3. So what we have learned in phase 1, in the phase 1 total productivity increases at an increasing rate from 10 to 30, the jump is 20. Now you can find that in the curve. See, from 0, the point of origin, the total productivity is increasing at an increasing rate from 0 to Q. See what I have written the comment for phase 1. Between 0 and Q, TP increases at an increasing rate. What happens to marginal productivity? What we have learned? Marginal productivity is also increasing from 10 to 20. So in the curve it is very clear, from 0 till P, marginal productivity is also increasing. Okay, so in the case of total productivity, from 0 to Q, TP is increasing at an increasing rate. From 0 to P, MP curve is also increasing, because in the upper part I have drawn the TP curve and in the lower part I have drawn MP curve, the same two curves which we have learned in the last video. Now, so MP also increases. So the first phase is over. Second phase, that is this middle part, between Q and M, this is Q and this is M. So, did you see this particular point? Fifth labor. What is happening? There we can find total productivity is at its maximum, 52. Now, there the marginal productivity is 0. We have learned when total productivity is the maximum, marginal productivity will be 0. And that is happening in the fifth unit of labor. We will consider only that because the increasing unit of labor is represented. Now, see, from Q to M, you can find at point M, the total productivity is the maximum, the value 52, and marginal productivity at the fifth unit you can find it is 0, and I have marked it with the letter S. So, M is the maximum point of TP and S is the 0 value of MP. So, second phase you can see between Q and M, TP increases at a decreasing rate and MP falls and reaches 0. So, second phase is a phase where TP is the maximum and MP value becomes 0. Now, the third phase is, this is a third phase. All of you look at here, this is a third phase. Third phase you can find. What happens in the third phase? Just to see what is happening in the third phase. In the third phase, TP is falling after point M, beyond M. TP is falling. What is happening to MP? MP is falling and becoming negative. Negative. Here you can find negative value. So, in the third phase, in phase 3, that is beyond point M, TP falls and MP becomes negative. So, these are the three phases based on the table. Now, you can see this figure once again. From 0 to Q, TP increases at an increasing rate. From 0 to P, MP also increases. Between Q and M, TP increases but at a decreasing rate, but whereas MP falls. What is this happening? Because you know that initially at second unit of labor, TP is increasing at an increasing rate. From 2 to 5, that means when the labor numbers are added, when we are increasing the number of labor, what happens in the second stage? TP increases but at a decreasing rate. At that time, MP is falling. Then TP reaches the maximum at fifth unit of labor, where MP is 0, which is marked as S. In the third phase, TP is falling and MP becomes negative. So, these are the three phases of law of variable proportion. Now, you can find point Q. This point Q is the point of inflection. Why it is known as a point of inflection? Because it is that point from where TP is showing a change. That means TP is increasing but only at a decreasing rate, and there reaches the maximum at point M. So, this is with regard to the three phases of the law of variable proportion. Now, why these three phases? Why the three phases are represented there? What are the reasons for the law of variable proportion? Now we have to learn that. Now phase 1, phase 2 and phase 3. Why it happens? Why TP is behaving at an increasing rate in phase 1? Why TP is increasing at a decreasing rate in phase 2? Why TP is falling in phase 3? We have to learn that. That is reasons for the law of variable proportion. So we will learn it phase 1. So we will learn first for phase 1. What is the peculiarity of phase 1? TP increases at an increasing rate. Why TP increases at an increasing rate? We need to know the reason, isn't it? So first 2 units of labor. In the table you can find for the first 2 units of labor, TP is increasing at an increasing rate from 10 to 30, and we have written it as the stage of increasing returns. Why is it like that? Just imagine, I will give you 2 examples which will be very easy to follow. Now take an example of a factory. Okay, in a factory, you know, let us assume the factory is a bread manufacturing company. Okay, bread manufacturing unit. Now for the bread manufacturing unit, there will be different machines where different workers are there. Now each worker will be assigned with a particular machine, and this worker will be standing in front of that machine to operate that machine. So we are assuming that our product is bread and workers are there in a bread manufacturing company, and each worker will be standing in front of a machine for its proper management, and the process of bread making will take place as we assign the work to the machines, right? So each and every machine will be assigned with a particular number of workers, or in some machines, in front of a machine there will be only one worker. Only one worker is needed so that the process can be done in a better way. Now that is one example. Now in the phase 1, let us imagine that a particular worker is standing in front of a machine. Now he is doing his work. He knows what has to be done. The bread which is being made with the other process, finally if it is coming out, it has to be packed up. That is the work. So different works are there for each and every worker. Now if a worker is standing in front of a machine, he knows what has to be done. He is very well trained what has to be done when he stands in front of that particular machine. His work is well defined. So one machine and one worker is the ratio, 1:1. So what is the ratio? 1:1. One machine and one worker, and that worker is standing in front of that machine and he knows what work he has to do. His work is well defined and he is very much comfortable there, and he has become very efficient in doing his work. Okay. Now, or we can say in front of that machine, sometimes 2 workers will be needed. Okay, instead of 1 worker, 2 workers will be needed. There are some machines where 1 worker is needed or 2 workers are needed. Okay, 2 workers are needed. That is also an example for us. So these 2 workers, or in the case of 1 worker, they are comfortable, or that particular person is comfortable while standing in front of that machine. Okay, that work is well defined. Now, so here we are taking the example of 1 labor and 2 labors. Okay. 1 labor in front of a machine and 2 labors in front of a machine. They are comfortable and the work is like that. They are well defined. Work is well defined and they are doing their work efficiently. So we are talking in the case where 1 worker in front of 1 machine or 2 workers in front of 1 machine. Okay. Sometimes a machine will have only 1 hand which has to be operated by only 1 worker. Sometimes a machine will have 2 hands which has to be operated by 2 workers at a time. So it depends. That is why the first unit of labor and 2 units of labors. Okay. Now here I have told you that a particular worker knows what has to be done when he stands in front of a machine. Okay. He is very efficient in doing that work. In that case, we can say that the fixed factor here, which is a fixed factor here, machine, is utilized in a proper way. There is no time lag or nothing. The work is done properly. So there is a better utilization of fixed factor. Which is a fixed factor here? Machine. That 1 worker is utilizing that machine properly or 2 workers are utilizing that machine properly. They know what has to be done when they stand in front of the machine. Okay, increased efficiency of variable factor. Which is a variable factor here? Labor is the variable factor here. And this labor know what has to be done when he stands in front of the machine, or these two labors know what they have to do when they stand in front of the machine. So their work is getting efficient. They are becoming fast and efficient in doing their work. So here we can say there is a good combination between the variable factor and fixed factor. Either it is 1:1 or 1:2. That is the proper ratio. All the works are going on fine. There is no interruption. Everything is okay and everything is fine. Machine is also utilized properly. Workers are also utilized properly, and there is a proper combination. Now, the second stage. If the producer want to increase the output, I told you if the production of shirt is only 150 and if he wants to increase the production of shirt from 150 to 200 or 300 or 300 or 400, he is thinking of increasing the labor variable factor from 2 to 3, 3 to 4 and 4 to 5. I am going to talk about the second phase where the workers ranges from 3 to 5 variable factor. Variable factor is labor. Now, if the owner of that particular factory is trying to increase the number of laborers, what will happen? Now, only one machine is there. Machine is fixed. The law of variable proportion says that when we increase the quantity of variable factor, labor, by keeping the quantity of fixed factors to be constant, which is a fixed factor here, machine. We cannot change the quantity of fixed factor here. Only one machine is there. Now with one machine, if the owner or if the producer is trying to increase the number of laborers from 2 to 3, 3 to 4 or from 4 to 5, what will happen in that particular case? One machine and 5 workers, what will happen? Now you can find there will be some disturbance among the workers because each and every fixed factor has a combination, either 1:1 or 1:2. If it becomes 1:3, 1:4 or 1:5, 1 means fixed factor, which is machine. 2 means labors. 3, 4, 5, all those variable factors are labors. So in front of one machine, how many labors are there now? Latest 5 labors are there. If there are 5 labors in front of a machine, the work of each worker will not be defined. They don't know what to do, who has to do which work in front of a particular machine. Totally confused. What has to be done? A proper combination is not there between the variable and fixed factor. So that is the reason why total productivity is increasing only at a decreasing rate. Initially, in the first phase, each and every worker know what has to be done. His work is well defined. Therefore, there is no confusion there. Both fixed factor and variable factor are utilized in a proper way, optimum utilization. Therefore, total productivity increases at an increasing rate from 10 to 30. But here in the second phase, you can find number of labors are increased, and in front of one machine, now we have 5 labors instead of 2. So ratio has become 1:5. That is not a good ratio because these workers doesn't know what has to be performed in front of standing in front of a machine. Totally confused. There is no proper coordination between fixed factor and variable factor. So optimum combination of factors not maintained here. This ratio 1:5 is not a good ratio. Okay, only one machine and 5 workers is an utter waste. Imperfect substitute. What substitution is given here? Here the producer has substituted labors with machine. Actually machine number has to be increased, but what he has done, number of labors has increased. This is not a perfect substitute. It is an imperfect substitute. If there is an imperfect substitute, there won't be any proper coordination between labor and the machines. That is why total productivity is increasing at a decreasing rate, and however it reaches the maximum, but whereas you can find marginal productivity is 0 here. Isn't it? Because labor is not properly utilized here. 5 labors in front of a machine is not a good ratio. Now that is why total productivity is increasing at a decreasing rate in phase 2 and marginal productivity becomes 0. Now let us move on to the third phase. What is happening in the third phase? Total productivity starts falling and marginal productivity becomes negative. That means when one more unit of labor is added, that means 6 labors. So what is the ratio now? 1:6, 1 machine and 6 labors. The situation has become worse, isn't it? In front of a machine, 6 labors. What to be done? No division of labor. Nobody knows what has to be done. Everyone will stand in front of the machine. No work will happen. There is an utter confusion. One person will say he will be doing that work. Another person will think that he has to do the work. So there is no proper coordination. So totally confused in that particular area. 1 machine and 6 workers is an utter waste. That is why total productivity is falling and marginal productivity has become negative because no contribution from the workers. Everybody is confused what to be done. Now see limitation of fixed factor. What do you mean by limitation of fixed factor? Why in this stage total productivity is falling and marginal productivity is becoming negative? Because we can say there is a limitation for fixed factor. What is a limitation of fixed factor? Which is a fixed factor here? Machine. Machine has got a limitation, isn't it? 1 machine and so many number of workers will not help for anything else. So there is a limitation for fixed factor. Fixed factor is, there is a limitation for fixed factor. Fixed factor has to be combined with proper ratio. 1:6 is not a proper ratio, isn't it? Either 4:6 or 6:6, that has to happen. This is not a proper combination. Poor coordination between variable and fixed factor. Nobody knows what to be done. So there is no proper coordination between the fixed factor and variable factor. Now decrease in the efficiency of variable factor. I told you the workers are not defined with their work. So the division of work is not there. So division of work is not there. It is absent. So what happens? As there is no division of work, nobody is assigned with a particular job. Everybody is standing in front of a machine. They are standing idle. They don't know what to be done. So their maximum manpower is not utilized. Manpower utilization is 0 there. That is why we say decrease in the efficiency of variable factor. Here the variable factor is not properly utilized. They are standing idle. They don't know what has to be done. There is no work defined to each and every person. There is no division of labor. So as there is no division of labor, the variable factors are not properly utilized. Therefore, in phase 3, we can experience total productivity to be falling and marginal productivity to become negative. So there should be a combination of fixed factor and variable factor. Then only we can expect that kind of increase in total productivity as well as in the marginal productivity. I hope it is very clear to you. So we were learning about the reasons of law of variable proportion. In the first phase, what is the reason? In the first phase, we can find total productivity is increasing at an increasing rate. Marginal productivity is also increasing, isn't it? So what is the reason behind that? Because there is a proper utilization of fixed factor and there is increased efficiency of variable factor because there the ratio was good. In the second phase, we can find total productivity increases but only at a decreasing rate, isn't it? But whereas marginal productivity falls. What is the reason behind that? The reason is optimum combination of factors is not maintained. Imperfect substitute. That means 1 machine in front of 1 machine, 3 to 5 labors is not at all a good combination. Then the third phase, we can find total productivity falls, marginal productivity becomes negative. What is the reason behind that? Because there is limitation of fixed factor. 1:6 is not at all appropriate. Proper coordination between variable and fixed factor. 1:6. Proper coordination between variable and fixed factor will never happen. decrease in the efficiency of variable factor. That means in front of a machine 6 workers, their work is not defined, division of work is not there. Therefore, in the third stage, total productivity will fall and marginal productivity becomes negative. So these are the reasons for the law of variable proportion based on the 3 phases. And I hope this law of variable proportion is very clear to you, and this is very, very important from the examination point of view. Thank you.